Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step-by-step analysis of prostaglandin E1, compound 1. Part A, functional group not present. Looking at the structure of prostaglandin E1. Ketone, C is equal to O on the cyclopentane ring present. Alcohol, of groups on the ring and side chain present, 2 of groups. Carboxylic acid, Co at the end of the upper chain present. Alkene, C is equal to C double bond in the lower side chain present. Nitrile, CN not present anywhere in the structure. Therefore answer A is equal to E, unnitrile. Part B, number of stereogenic centers. A stereogenic, asymmetric, center is a carbon bearing 4 different substituents. Examining the cyclopentane ring and side chains. C2 of cyclopentane bears H, the carboxylic acid chain, the ring bonds stereogenic. C3 of cyclopentane bears H, the alkene chain, the ring bonds stereogenic. C4 of cyclopentane bears O, H, 2 different ring carbons stereogenic. C5 of cyclopentane bears H and connects ring to C4 and C1 stereogenic. The allylic carbon bearing O in the lower chain, sp3, 4 different groups stereogenic. Total is equal to 4 stereogenic centers, C8, C11, C12, C15 in prostaglandin numbering, or equivalently the 4 sp3 chiral centers in the molecule as drawn. Therefore answer B is equal to B, 4. Part C, number of sp2 hybridized carbons. sp2 carbons include all carbons involved in C is equal to O double bonds and C is equal to C double bonds. Ketone carbonyl carbon, C is equal to O on ring 1 sp2 carbon. Carboxylic acid carbonyl carbon, C is equal to O of Co1 sp2 carbon. 2 alkene carbons, C is equal to C in the lower side chain to sp2 carbons. Total sp2 carbons is equal to 1 plus 1 plus 2 equals 4. Therefore answer C is equal to D, 4. Part D, geometric configuration of the double bond. The double bond in the lower side chain connects the cyclopentane substituent side to the hydroxyl-bearing alkyl chain. Applying CIP priority rules. On the carbon attached to the ring carbon side has higher priority than H. On the other alkene carbon, the CH, or CH to CH to CH to CH3 side has higher priority than H. The 2 higher priority groups are on opposite sides of the double bond, trans arrangement, giving E configuration. Therefore answer D is equal to AE. Therefore, the correct answer is AE, BB, CD, DA. The correct answer is shown on screen.